Hey guys, today I want to go over the heating earth notes. So heat is the energy transferred from one object to another because of its object's difference in temperature. Keep in mind that I'll be going through with both the PowerPoint here and the notes on the side here. So heat is the energy transferred because of the object's difference in temperature. Okay, temperature is a measure of the average kinetic energy of the individual atoms or molecules in a substance. We also call this heat energy. One of the misconceptions that we find throughout high school students and most people for that matter is they associate heat with things being hot, and that's not always the case. Heat is a type of energy. So even things that are cold have heat energy. So don't always associate things that are hot with being heat and things that are cold with having no heat, because it all revolves around heat energy. It's just things that are hotter have more heat energy than things that are colder. Okay, moving on. We'll talk more about electromagnetic waves in further units, but just to get a brief glimpse here, the sun emits light and heat as well as ultraviolet rays. Okay, those are the things that would cause a suntan while at the beach or something like that. But these forms of energy are only part of a large array of energy emitted by the sun called the electromagnetic spectrum. Okay, and that goes here. And you can see here in this diagram that only the types of light you can see are visible light right here. Okay, and that's only a small portion of the electromagnetic spectrum here. There are many different forms of light that we still cannot see. However, we know exists because we understand things like X-rays, if you've ever been to the doctor and had an X-ray, microwaves or things that can cook your food, television, FM radio, all right, or different types of radio waves. Okay. This is probably one of the most important concepts in this PowerPoint that will continue to come back through as we go through later units here. But the three mechanisms of energy transfer are conduction, convection, and radiation. You can see conduction here. Conduction is a transfer of heat through matter by molecular activity, basically molecules bumping into one another. Convection is the transfer of heat through mass movement or circulation within a substance. And you can think convection as air or water. When things are heated by air or water, or the movement of those things, consider it convection. And those are right here, conduction and convection. And then last but not least, radiation, which is the transfer of heat through electromagnetic waves. Okay, so unlike conduction and convection, which needs a material to travel through because they need those molecules, conduction needing molecules bumping into each other, and convection needing air or water, radiation can travel through a vacuum. And I'm not talking about the vacuum that somebody uses to clean their house. A vacuum means that space is void of all material, like space. So electromagnetic waves can travel through space, radiation can travel through space. And this is how we get our energy from the sun. Okay, so that goes here as well. Okay, all objects at any temperature emit radiant energy. So all things will radiate heat energy. So if you have a thermos, or a vacuum-walled thermos, most of what that means is that there's an outer layer, and then there's a vacuum in between that outer layer and an inner layer. And so heat can't escape through that by conduction or convection. So it's able to keep ice colder longer. It's able to keep hot things hotter longer. But all things radiate heat, so it'll still lose its heat energy or gain heat energy from the outside through radiant energy. It'll just take much longer because those other forms of heat transfer aren't in contention for that. Okay, like I said, hotter objects will radiate more heat energy. The hottest radiating bodies will produce the shortest wavelengths of maximum radiation. And things that are good absorbers of radiation are also good emitters as well. Okay, so what happens to solar radiation? Three different things that we can talk about here. Some energy is absorbed by the object, which will go here. Substances such as water and air are transparent to certain waves of radiation, so it'll pass straight through. And some radiation may bounce off the object and go back to where it came from. Okay, you can see a diagram of that here. Some goes straight to the ground and is absorbed, some passes straight through, and some is reflected back into space. Okay, so reflection. Reflection occurs when light bounces off of an object. Think seeing your reflection in a mirror. It's the same thing, that light is bouncing off of that and back into your eye so that you can see yourself in the mirror. Okay, reflection reflectant radiation will have the same intensity as incident radiation. So you'll be able to see it at the same intensity that it's coming off as. Scattering produces a large number of weaker rays, think passing through something and scattered off in all direction. Okay, and absorption, so about 50% of the radiation that comes from the sun is absorbed by Earth's surface, okay, or by the atmosphere. Okay, and this is called the greenhouse effect when that radiation is absorbed. And the greenhouse effect is actually a good thing in smaller doses, contrary to what you might have heard. A lot of people attribute global warming to the greenhouse effect, and that can be the case, but the greenhouse effect is important because it regulates those temperatures on Earth and allows Earth to stay warm instead of going through periods of intense heat and cold throughout the day. Okay, so you can see that here as well, and a picture of the greenhouse effect. And we'll talk more about the greenhouse effect when we get further on. All right, so there are other factors other than latitude that increase or influence temperature. Okay, so why land temperatures vary? Land and water have a specific meaning in this, and we'll talk more about this in Unit 4 as well. But land heats more quickly and to higher temperatures than water. Land also cools more rapidly, and this is due to a property called specific heat that both of these things have. Water has a very high specific heat, which causes it to take more energy to heat up and cool down. Specific heat is the amount of energy that's required to raise 1 gram of a substance by 1 degree Celsius, and that allows water to heat up and cool down slower than land, which has a low specific heat, while water has a high specific heat. We can talk about windward and versus leeward coasts here, which have prevailing winds blowing across the ocean. Windward coasts will experience cool summers and mild winters, versus leeward coasts that have prevailing winds blowing from dry land, and they'll experience a more normal continental pattern here. You can see that here. Okay, altitude can have an effect. Generally, it's going to be colder at higher altitudes than at lower altitudes. Okay, geographic positioning as well is going to have an effect. Think of it being hotter in Florida than it probably is in New York. Cloud cover and albedo. Albedo is the fraction of total radiation that's reflected by any surface, and many clouds have a high albedo and therefore reflect back into space a significant portion of the sunlight that strikes them. So on a cloudy day, chances are it's going to be cooler than it is on a sunny day. Okay. And ocean currents being the 5th one. We'll talk more about ocean currents in the 4th unit, but you can see here how a warm current could affect climate versus a cold one. And that is all for this PowerPoint. We'll get to the next one soon.